Chapter 12, Sample Problem 1. 5 hypothetical planets have the masses and radii shown below. Consider the surface gravity of each of these objects and check the appropriate box. So, first, a couple of things to really point out here. One, we're looking for the surface gravity, or the G, that you have on each planet. And two, this is clearly our base planets. This is just the generic M and R. So we want to go back and say, well, how do we find that? And we say, well, the weight that we're used to, which is mg, must be generated by the gravitational force between objects, which is the Newtonian law, g times the mass of the planet times the mass of the object over the distance squared. But of course, on the surface of the planet, we're at a distance which is the radius of the planet. Like when we're talking about falling here, we're at the radius of the planet. And we see, technically we usually call this G effective. So G on the planet is big G times the mass of the planet times the radius of the planet squared. So we can see that, for instance, in case B, in case A, we'll say this is a value of 1. That's our standard guy. Then in case B, the value would be twice as large because of that, but the same because of R, which means we end up with just twice as large. So the value here would be 2. And in C, we can see that we have the same mass on top, but we have 4R on the bottom, and we notice carefully that 1 over 4R squared becomes 1/16 1 over R squared. And so this is actually 1/16 of the original amount. For option D, we have 4 times the mass on top, but we have 2 times the radius on the bottom, but we square it, so that becomes 4 times the mass over 4 times the radius squared, or the same as A. And so this is also a value of 1. And then finally, we have, in E, we have 4m over 4r quantity squared, which is 4m over 16r squared, which becomes 1/4 m over r squared. So this is 1/4. And now we can see pretty clearly and pretty easily what our orders are going to be. So we have the largest is B, and then we have A and D are equal, and then we have E, and then we have C.